One of the questions I get asked most often is, what are all the default DMX fixtures in Unreal Engine and what do they actually do? Unreal Engine ships with a surprisingly capable collection of built-in DMX fixtures that are ready to be used straight out of the box. Whether you're visualizing a live event, experimenting with virtual production, or simply learning Unreal DMX, these fixtures provide everything you need to start building lighting shows. The challenge is, when you first open the DMX template, it's not immediately obvious what each fixture does, how it's controlled, or when you should use one over another. So that's exactly what we're going to cover today. We'll go through every built-in fixture that currently ships with Unreal Engine, excluding the Matrix fixture, which deserves a tutorial on its own. I'll explain what each fixture does, how to control it, and where it fits into a real lighting workflow. Then, once you know what every fixture is capable of, I'll show you how to recreate this exact demo from scratch. We'll build a brand new Unreal project, connect it to the free GrandMA Dot2 lighting console, and overcome one of the biggest frustrations almost every beginner eventually runs into: the fixture profiles. Most lighting consoles don't include profiles for Unreal's built-in fixtures, making them difficult to patch and control. That's exactly why I created the digital proving ground Dot2 fixture profiles. They're completely free and I'll show you exactly how to install them so you can start experimenting right away. So let's stop stalling and jump straight into the fixtures. The built-in fixtures. I've placed the GrandMA Dot2 alongside the Unreal viewport so you can see exactly how each fixture responds as we control it. We'll start with the simplest fixtures and gradually work our way towards the more specialized effects. The strobe. Let's start with the simplest fixture in the collection. The strobe is a 2-channel fixture that does exactly what the name suggests. Raise the dimmer channel to turn the lighter on. Then adjust the shutter channel to control the strobe effect. As you move through the DMX values, you'll notice the flash speed and the behavior changes. These shutter effects are built into Unreal Engine, so every fixture that uses this attribute behaves consistently. Although it's a simple fixture, it's perfect for creating energy during musical hits, dramatic reveals, or high-energy moments in a show. The static head. If you've worked with live events before, think of it as a basic LED par can. It gives you intensity, RGB color mixing, and the same shutter control we looked at. Press Add to bring the intensity to full. Then head to the color controls and mix any color using the red, green, and blue channels. You'll also find the familiar shutter channel for adding strobe effects. This is the fixture I'd reach for whenever I need simple color lighting without movement, for instance, uplighting or architectural lighting. The LED wash. The LED wash builds directly on the static head. Everything we just covered is still here, but now we also have a pan, tilt, and zoom. I'll set the intensity to 80% by typing at 80 please. Using the position controls, we can aim the fixture anywhere in the scene. Then, under focus, the zoom channel adjusts the beam angle. If you're lighting scenery, stages, or large environments, this is usually a better choice than the static head because it gives you much more flexibility. The moving head. Now we get to one of the more versatile fixtures in the collection. The moving head includes everything we've already seen: intensity, pan, tilt, zoom, and strobe. But it also introduces 3 new features: gobos, frost, and a color wheel. Open the gobo controls and scroll through the available values. You'll see Unreal cycle through a range of built-in beam patterns and effects. They're great for adding textures to floors, walls, and scenery. If you'd like to create your own gobos, I've made a separate tutorial that covers this workflow. The frost channel can be used to soften the gobos. You'll also notice the focus attribute. It isn't implemented in any of the fixtures. It's a good reminder that not every published attribute will necessarily have a function, so it's always worth testing a fixture rather than relying solely on the channel list. One important difference compared to the LED fixtures is color. Instead of RGB color mixing, this moving head uses a predefined color wheel. That means you're limited to the colors on the wheel unless you extend the fixture yourself. The good news is that these fixtures are designed to be extended, and we'll see an example of this in just a moment. The moving mirror. The moving mirror works very much like the moving head. Instead of moving the entire fixture, it redirects the beam using a motorized mirror. You'll find the same core controls: intensity, pan, tilt, gobos, color wheel, frost, and strobe. If you've learned the moving head, you've already learned the moving mirror. The choice between them depends on your particular taste, but mirrors are considered more retro. Now that we've covered the core lighting fixtures, let's move on to Unreal's built-in effects. The Pyro. The Pyro is about as straightforward as it gets. Once the dimmer value rises above 50%, the effect fires. To trigger it again, simply bring the value back below 50% before raising it again above 50%. If you set the shutter value above 50%, it becomes a continuous effect instead of a single fire. It's simple, effective, and perfect for accent moments, countdowns, or musical hits, and much safer than the real thing. The Fountain. Like the Pyro, raising the dimmer above 50% activates the effect. What makes this fixture different is the shutter channel. Instead of controlling a strobe, it adjusts the pressure of the water jet. Lower values produce a gentle fountain, while higher values create a much more energetic effect. I'll leave the fountain running while I look at the fixture design to complement this. The Fountain Light. The Fountain Light is actually one of my favorite fixtures in the demo because it demonstrates a really good Unreal workflow. It isn't one of the fixtures that ships with a plugin. Instead, Epic duplicated one of the built-in fixtures and extended it specifically for the water fountain example. That's exactly the approach I'd recommend in your own projects. Duplicate a fixture, extend it to suit your needs, and leave the original untouched. If you're interested in how this works, drop it in the comments below and let me know. Functionally, it behaves the same like the static head. You still have the intensity, RGB color mixing, and shutter control, but it also adds zoom, making it much easier to light the fountain effectively. I'll position it close to the water effect. Set the intensity to full, choose a cyan color, then adjust the zoom until the fountain is evenly illuminated. It's a simple extension, but a great example of how these fixtures are intended to evolve. The Laser. Next, we have the Laser. Raising the dimmer value above 50% enables the effect. The interesting controls here are focus and zoom. Focus changes the number of laser beams being generated. Zoom controls the spread between the first and the last beam, allowing you to create anything from a tight cluster to a wide fan. With just a couple of parameters, you can create a surprising variety of looks. You can change the color of the laser from the details panel. The Firework. Last but certainly not least, the Firework. It's controlled by a single DMX channel. Raise the dim above 50% and the firework launches. To trigger another, simply bring the value back down below 50% before raising it again. Most of the creative controls actually happens inside the blueprint itself. In the details panel, you'll find the options for the firework, color, the delay before the explosion, the trail effect, and the explosion style. This means you can create a wide variety of fireworks while still triggering them from a single DMX channel. And that's it. That's every built-in DMX fixture that currently ships with Unreal Engine, excluding the Matrix fixture. Hopefully now you have a much clearer understanding of what each fixture does, how it's controlled, and more importantly, why you choose to use one over another. Now that you know what these fixtures are capable of, let's recreate this entire demo from scratch so you can start experimenting in your own projects. I'll be using Unreal 5.8 throughout this tutorial, but if you're using Unreal 5.5, 5.6 or 5.7, don't worry, the DMX workflow is almost identical. Start by creating a new project using the DMX template and call it Start a Fixture Demo. Once the project has finished loading, the first thing I like to do is organize my own content. Inside the content folder, create a new folder called Start a Fixture Demo. Then create 3 subfolders: Meshes, Fixtures, DMX. It only takes a few seconds, but keeping your own assets organized becomes invaluable as projects grow. Rather than rebuilding the demo environment, we'll reuse the floor mesh that's already included in the template. Select the floor in the level. In the Details panel, click the magnifying glass next to the static mesh. That jumps directly to the asset being used. Copy it into your Meshes folder. We'll use our own copy from this point forward. Now let's collect the built-in fixture blueprints. Select any fixture already placed in the template and press Ctrl B. It instantly reveals the selected asset inside the content browser. If you don't see the engine or plugin content folders, enable them from the content browser settings. From there, navigate to the DMX Fixture folder. Enable the Blueprint class filter to make the fixtures easier to find. You'll notice that there are several blueprint components and supporting blueprints in these folders. For this tutorial, we are only interested in the actual fixture blueprints that we'll be placing in the level. There's no need to copy the blueprint components or the fireworks shell blueprint. Copy only the fixture blueprints into your own fixtures folder. One fixture is missing. The fountain light isn't part of the Unreal Engine plugin. Instead, Epic created it specifically for the DMX template project by duplicating and extending one of the built-in fixtures. Copy the fountain light from the template folder into your fixtures folder as well. Make sure the blueprint folder is still enabled to find it easier. At this point, we now have our own editable copies of every fixture we'll be using. Next, create a new level called Starter Fixture Demo _PL. The PL simply stands for Persistent Level. Open the new level. It'll be completely black. Open the Environment Light Mixer and create the default lighting components. Before we continue, let's make one small change that will make working much easier. Add a post-process volume to the level. Enable Infinite Extent Unbound in its details so it affects the entire scene. Then lock the exposure so it no longer auto-adjusts as we move around the level. While you're there, disable lens flare as well so it doesn't become distracting with the bright lights. Now we're working with a more predictable viewport. There's a deeper explanation on this I cover in my DMX tutorial series. Next, drag the floor mesh with the meshes folder into the level and reset its transform. The floor already has a useful grid pattern, so I'll use that to keep all the fixtures evenly spaced. Now drag one copy of every fixture into the level. Some fixtures need a little extra attention, so I'll raise the moving mirror and the laser slightly above the ground so they don't clip through the ground. Don't worry too much about creating the perfect layout. The goal here is simply to create a clean demo scene that's easy to work with. With the scene ready, let's connect the lighting console and get everything talking to Unreal. Connecting Dot2 and Unreal. For this part, I'll be using GrandMA Dot2. I like recommending Dot2 because it's completely free, includes one free DMX universe, and is a great way to start learning Unreal DMX without investing into a console. If you've already followed my Unreal DMX beginner tutorial, you'll probably already have it installed and ready to go. Before we start patching fixtures, there's one problem that almost every beginner eventually runs into. Unreal ships with the fixtures, but most lighting consoles don't ship with the fixture profiles needed to control them. That's exactly why I created the digital proving ground Dot2 fixture profiles. They're completely free, and you'll find the download link in the description. Find the landing page and prompts, and you'll find a link to the folder where I plan on storing all my free guides and assets in the future. Download the Dot2 UE Starter Fixture folder. Extract it. Then copy the files into the Dot2 library folder located within your app data folder. If you're not sure where to find it, I'll put the path on screen as well as in the description. Once the profiles are installed, launch Dot2 and create a new show and give it a name. Open Patch and Fixture Schedule. Choose Add New Fixtures. Select Other, then search for TDPG. If everything was copied correctly, you'll now see all the Unreal fixture profiles. Ignore the extra fixtures in my list. That is for a future project I'll share in time. Patch one of each fixture starting with a firework. One recommendation I'd make is to keep the fixture order the same as the order you'll use inside Unreal. It's not required, but it makes the rest of the setup much simpler. Once everything has been patched, save your show. Next, open the network interface. I'm using my Ethernet adapter, but if you're running everything on a single machine, you can also use the loopback adapter. After selecting a network adapter, you might be asked to restart the software. After restarting, head to Network Protocol. I'll be transmitting DMX using SACN. I'll enable both SACN and ArtNet. Once enabled, make note of the IP of the network adapter. We'll need that inside Unreal Engine. With Dot2 ready, let's switch back to Unreal. Connecting Unreal. Open Project Settings and scroll down to the DMX section. Remove all existing input ports and create a new SACN input port. Select the same network adapter or IP address you configured in Dot2. If you're using the loopback adapter, you can use 127.0.0.1. And if loopback gives you trouble, 0.0.0.0 is often a reliable fallback. Before we patch a single fixture, let's make sure Unreal is actually receiving DMX. Open the DMX activity monitor and make sure you see some values. If you can see some active values, you're connected. If not, stop here and solve the communication problem before moving on. There's no point in moving on and patching the fixtures until you know the DMX is working correctly. I cover this in my Unreal DMX tutorial series as well. Creating the DMX library. Let's create our own DMX library. Inside the DMX folder, create a new DMX library and call it demo_DMX. Rather than rebuilding every fixture definition from scratch, we'll reuse the ones Epic has already created. Open these two template DMX libraries. Copy the fountain and fountain light fixtures from the water fountain library. Then copy the remaining fixtures from the main fixture library, excluding the matrix fixture. If you like, there's also a good opportunity to remove the automatically generated 001 suffixes from the name to keep everything clean and easy to read. With the fixture types in place, switch to the Fixture Patch tab. Patch the fixtures in exactly the same order you used in the Dot2. This is where that little bit of planning pays off, because the fixture order matches. The patch is quick, clean, and easy to follow. Save the library. The final step is linking the DMX patches to the blueprints in the level. Open the Patch tool from the DMX menu and select your Demo DMX library. Working from the top of the list, select each fixture patch. Then assign it to the matching blueprint in the scene. You can do this by either selecting the blueprint in the viewport or selecting it from the outliner. Once you've assigned the final fixture, bring up the demo on the console. If the fixture responds, congratulations! You've successfully recreated the entire demo. From here, have some fun and experiment. And now, it becomes easier to apply these principles to your own projects. Hopefully this video has given you a much better understanding of the fixtures that ship with Unreal Engine and how they're intended to be used. Don't forget to download the free Digital Proving Ground Dot2 fixture profiles using the link in the description if you haven't. They're designed to save you time and make it much easier to start programming Unreal's built-in fixtures. If you'd like to see more Unreal DMX and virtual production tutorials, consider subscribing. And if there's a topic you'd like me to cover, let me know in the comments below. Have some fun and play with the template you made. Go imagine, create, and see if it goes boom.